Long after it finished flying past the giant planets, Voyager 1 was given one last strange assignment: turn around and photograph everything it was leaving behind from almost 6 billion kilometers away. The result was a fragmented family portrait of the solar system, tiny colored specks suspended in darkness, including a single pale pixel of Earth caught in a sunbeam. Decades later, that camera is still off, but the spacecraft is still talking to us from interstellar space. In this video, we'll revisit those final images and what they quietly say about the mission and about us. Let's get started. On February 14th, 1990, more than 12 years after launch and long after its encounters with Jupiter and Saturn, Voyager 1 was coasting out of the planetary neighborhood when mission planners gave it an odd final job: turn around and look home. Its cameras had been built to grab close-up views of cloud bands, rings, and moons, huge targets filling the frame, not faint pinpricks scattered across a sky dominated by sunlight. From nearly 6 billion kilometers away, every planet was just another dim dot, easily drowned in glare. Still, engineers commanded Voyager to sweep its gaze back across the inner solar system. Over the course of the sequence, it captured 60 narrow frames, later stitched into what became the Solar System Family Portrait. The result was deliberately underwhelming in a visual sense. Venus, Earth, Jupiter, Saturn, Uranus, and Neptune show up as tiny specks. Mercury and Mars are lost in scattered light near the Sun. The giant planets that Voyager had once revealed in rich detail, Jupiter's storms, Saturn's rings, Uranus and Neptune's pale disks, are reduced to points barely different from background stars. Earth appears as the now iconic pale blue dot, a minuscule fleck suspended in a sunbeam created by internal reflections in the camera optics. That contrast is the whole power of the sequence. The same spacecraft that had turned distant worlds into places was now showing how small and fragile they look when seen all at once, from the edge. After transmitting the data, Voyager's cameras were shut down for good, ending its imaging mission, but not the mission itself. Other instruments would carry on into interstellar space, while the family portrait became one of exploration's most haunting postcards. Voyager's family portrait lands differently when you remember what came before it. Launched in 1977 to exploit a once-in-a-lifetime planetary alignment, Voyagers 1 and 2 used gravity assists to hop from one giant world to the next, turning a 4-year flyby plan into a wholesale rewrite of outer solar system science. At Jupiter, they revealed a violently dynamic atmosphere, bands, lightning, and a finely detailed great red spot, and caught Io in the act of erupting, proving tidal forces alone could power intense volcanism far from the sun. At Saturn, they transformed the rings from simple bands into a layered system of gaps, waves, and braids, and showed Titan's thick, hazy atmosphere was one of the most intriguing environments in the system. Voyager 2 then pushed on to Uranus and Neptune, the only spacecraft ever to visit them, uncovering tilted magnetic fields, narrow rings, supersonic winds, dark storms, and a geologically active Triton orbiting in deep cold. After all that close-up revelation, the family portrait did the opposite. It stripped the planets of detail and reduced them to points of light, emphasizing scale rather than features. That's why the pale blue dot hit so hard culturally. Earth is not shown as a recognizable world, but as a single, fragile pixel lost in scattered sunlight. A visual argument for both our smallness and our uniqueness. Shutting down the cameras in 1990 wasn't an ending so much as a pivot. With no more planets ahead, Voyager's remaining power was redirected to instruments that could sense fields, particles, and plasma at the edge of the heliosphere and beyond. The family portrait now reads as a hinge between two eras: Voyager, the planetary explorer, and Voyager, the interstellar probe, saying goodbye to the worlds it revealed before slipping into the dark between the stars. Today, Voyager 1 and Voyager 2 are no longer image-making spacecraft. Their cameras have been silent for decades, so the future of the mission is not visual. It is about signal, power, and measurement. Both spacecraft are now traveling far beyond the planets. They have crossed into interstellar space, meaning they are outside the main bubble of solar wind created by the sun. That does not mean they have left the solar system in every possible definition, but it does mean they are operating in a region no earlier spacecraft had directly explored. The main challenge now is power. The Voyagers rely on radioisotope power systems, which slowly generate less electricity over time. As power declines, mission engineers have to make careful choices. Some instruments must be shut down, so others can keep working. The goal is to extend the mission for as long as possible while preserving the most valuable measurements. This gives Voyager's final images a different meaning today. They are not just historic photographs. They are the last visual record from spacecraft that continued long after their cameras went dark. Every later update about Voyager's condition, distance, or power status is part of a mission that already gave us its final look back. The science that remains is still valuable. Voyager can measure conditions in the distant space environment, including particles and magnetic fields. These measurements help scientists understand the boundary between the sun's influence and the surrounding interstellar medium. Very few missions can provide direct data from that region, which makes every continuing signal important, but the mission is approaching natural limits. Eventually, the spacecraft will not have enough power to run instruments or communicate with Earth. When that happens, Voyager 1 and Voyager 2 will continue moving silently through space. They will no longer operate as active missions, but they will remain physical objects from Earth traveling through the galaxy. That future adds weight to the family portrait. The images were taken because the opportunity would never return. Voyager 1 could still turn back and see the solar system, but only once. After that, the cameras were no longer part of the mission's future. The broader implication is that Voyager's story is not only about distance. It is about how a mission can change purpose over time. It began as a planetary mission, became a deep space mission, and then became humanity's first direct exploration of interstellar space. The family portrait captures the moment between those stages. It also reminds us that exploration is not always about moving forward without looking back. Sometimes one of the most important acts is to turn around and see the place you came from. Voyager had already transformed our view of the outer planets, but its final images transformed our view of the solar system as a whole. Voyager's final images turned the solar system into a few distant points of light. Earth became almost invisible, but more meaningful than ever. Decades later, that last look back still shows how far Voyager went, and how small home really is.